Voyager didn't just capture dazzling photos of our gas giants and their moons, it captured the hearts and minds of generations back home on Earth. When I look back, I realize how little we actually knew about the solar system before Voyager, says Voyager mission project scientist Edward Stone. We discovered things we didn't know were there to be discovered, time after time. Two pioneers embarked on the most epic feats of exploration ever undertaken in 1977. And their ultimate goal was to unravel the cosmic mysteries surrounding the solar system and our place in it. Not only did they provide us with some of the first and best imagery of our solar system's outer planets, but they continue to send us incredible new information about our universe from interstellar space. Imagine 47 years later and 24 billion kilometers far away. The Voyager 1 and 2 probes are not just instruments and circuitry, but they are a symbol of humanity at its best. In today's video, we trace Voyager's iconic journey in pictures, from the splendor of Jupiter to Saturn's icy rings, to the topsy-turvy world of Uranus, to the mighty storms of Neptune. We explore what this mission taught us about our planetary neighborhood. On August 20th, 1977, NASA launched the Voyager 2 space probe from Cape Canaveral, Florida. Its accomplice, Voyager 1, was launched 2 weeks later on September 5th, 1977. Even though both probes were Jupiter-bound, Voyager 1 was set on a shorter, faster trajectory. After some back and forth with the US Congress, a few hurdles surrounding budget approvals, and a decade of hard work, the Voyager probes finally made it to the launch pad, heralding a new era of space exploration. The dazzling parade of pictures Voyager would send back were absolutely revolutionary at the time. Eventually, Voyager 1 overtook Voyager 2 on December 15, 1977, and exited the asteroid belt first. Together, this dynamic duo was set to take advantage of a once-in-176-year planetary alignment. Jupiter, Saturn, Uranus, and Neptune were going to be aligned in a way that would allow one mission to explore all four gas giants, an opportunity NASA simply refused to miss. 13 days after launch, Voyager 1 sent this photo back to Earth. The first of tens of thousands it would send back over the next 5 years. Taken 11.6 million kilometers from Earth, it's a sentimental place to start our journey. It might remind you of the Earthrise photo taken by the Apollo 11 crew from the Moon just 8 years prior. We can see our blue marble and its moon in the distance. It would be almost 2 years before Voyager 1 finally makes its approach to its first target, Jupiter, which is 714 million kilometers away. Voyager 1 arrived first on March 5th, 1979. It travels at 17 kilometers per second, 2 kilometers per second faster than Voyager 2, who, despite leaving Earth first, arrived 4 months later on July 9th, 1979. This is because the trajectory Voyager 1 took allowed it to gain more speed relative to the Sun. Now, Voyager 1 was not the first spacecraft to encounter Jupiter. That was Pioneer 10, 7 years prior in 1972. And while the Pioneer missions certainly provided great scientific insights, it didn't quite grab the imagination of the public. However, sending back stunning images like this, Voyager certainly did. This is Jupiter in all its glory. If you look closely, you can spot 2 of its moons, Io, one on the left, and Europa, the beige one on the right. Jupiter's moons, Io and Europa. Possibly the biggest shock from the Voyager expedition is the discovery of volcanic activity on Jupiter's closest moon, Io. Prior to Voyager, geologists thought Io would be covered with large impact craters, like our own moon. While they did find circular markings on Io's surface, they didn't appear to be from craters. The dark spots you can see indicate the presence of volcanic hotspots and lava lakes. This photo shows lava flow from less than 1 million years ago, which is incredibly recent and totally unexpected. We now know Io as the most geologically active site in the solar system. At the time of these pictures being taken, it would have been incredible to capture Io mid-eruption. Imagine expecting to see a moon similar to ours and then stumbling upon a sight like this. These blue explosions on the surface of Io shoot material and gas 100 kilometers into space. The volcanoes are incredibly active, going off relentlessly every few hours, treating Voyager to several jaw-dropping photos. The next moon out from Io is Europa, and it could not be more different. An icy world. Voyager 1 was the first to show us that Europa is covered by curious scratch markings. Scientists supposed them to be some type of ice fracture patterns on Europa's surface. It was also Voyager data that first suggested there might be a swirling ocean lurking under the ice. Today, we know of 95 moons orbiting Jupiter. However, prior to 1979, that number was 13. Voyager discovered 3 new satellites, Thebe, Metis, and Adrastea, bringing the total to 16 moons by the early 1980s. Sadly, we don't have any pictures of them from 1979, though they have been imaged since. Voyager 1 even recorded its approach to the Great Gas Giant. It took photos at regular intervals every 10 hours, or 1 Jupiter day. This means the planet is in the same point of its rotation in all the photos. The 66 photos were spliced together to create this time-lapse movie, spanning Voyager 1's approach to Jupiter from January 6th to February 3rd, 1979, covering a distance of 27 million kilometers. Well, decide for yourself if it is incredible or terrifying, but let's get a little closer and see what surprises this planet is hiding. Something that immediately stunned scientists was Jupiter's atmosphere. They expected to see east-west and west-east winds in Jupiter's different atmospheric zones. But what caught them by surprise was the amount of turbulence, plumes, and rotational movement, which are super clear in this picture. You can immediately see how dynamic the atmosphere over Jupiter is. Scientists had already suspected Jupiter's most notable characteristic, its great red spot, might be a counterclockwise rotating formation. Not only did Voyager data confirm this, it also showed a surprising amount of similar phenomena in other parts of the atmosphere. The white spot you see below the Great Red Spot is one example of these surprise storms. Turns out Jupiter's atmosphere is littered with them, and we had no idea. When we think rings, we think Saturn, but thanks to pioneer data, scientists have long suspected that the same is true for Jupiter. Voyager data not only confirmed the existence of 4 Jovian rings, it was also the first to image them. This picture taken as Voyager leaves Jupiter highlights the rings beautifully as that glowing orange line protruding from the planet. NASA's Voyager program gave us perspective on life in this pale blue dot of ours. Wouldn't it be nice if we could get more of that perspective in our day-to-day life? What are your thoughts about this mission? Comment down below. Subscribe to Space Centric Archives for upcoming educational videos related to space science. And press the bell icon. Thank you for watching this video until the end.